This video covers determination of unknown acid concentrations by acid-base reactions.
The unknown HCl and the unknown sulfuric acid by using known sodium hydroxide and usually inside of burette it's what we call the titrant, and in our case the slab titrant it's the sodium hydroxide, and the erlenmeyer flask and contains analyzer, and so in our case HCl and sulfuric acid. Our burette currently it's filled with the downlight water. So what you need to do is come to the sink, drink some off from the bottom part, and 4 or 5 milliliter, and then just simply dump everything. All right. Now we're going to do something we have done before, using sodium hydroxide to rinse about 1 or 2 milliliters. And now the faculty should review why we want to use rinsing technique. Well, that's because we're going to use whatever we're going to use to replace whatever was in it. And that it's the reason. All right, so now open it, doesn't come out, give it a shake. Now you can see. All right, I will purposely leave some of the air bubbles. Yeah, beautiful. All right, so we're going to remove. And then we're going to now fill our burette with our titrant, which is sodium hydroxide, all the way up past 0. Oops. Okay, and then we need to get rid of the air bubble from our tip of the burette. Get rid of this. So now you need to turn 180 degrees many times, but in one shot, all right, to get rid. Turn, the stop cock. So look what happens, all right? This is air bubble right here. So you turn that, ooh, still, see, right there. More, ooh, more. Come down more. Come down, keep going, that's 180. Now until no more air bubble comes out. And then you're going to lower the meniscus.
Avoiding any parallax error, record the lower meniscus of sodium hydroxide solution on page 76. Read the burette scale from top down. Consider the burette as an upside down graduated cylinder. Burette gives us the volume delivered or added.
On page 76, on titration 1, what would you write at the beginning? We have a 0, at the end we have a 25. Remember where the meniscus is, that is where your number is. So at the beginning we haven't delivered anything yet. Therefore, the initial burette reading is 0. For volumetric burette, the tolerance is 0.01 milliliter. All right, in other words, you must read 2 digits after the decimal point. So right here is 0. If the meniscus right here, just no more, no less, 0, then your reading should be 0.00.
Obtain your acid of unknown concentration in a 100 ml beaker. Place the pump at the back of pipette and rinse the pipette with a few milliliters of the given acid. Discard the rinsed solution in a trash beaker on your bench or in the sink. Pipette out 25.00 milliliter of hydrochloric acid accurately into a clean 125 ml Erlenmeyer flask. In the same flask, add 2 to 3 drops of phenolphthalein to indicate a visual color change from colorless to pink.
Okay, now move your meniscus. Dun, 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 dun. Yeah, beautiful. Right there. Okay, and now release. Like the gravity do its own work. And then make sure you understand, because this is not the first time we use volumetric pipette. So do not force the last drop or 2 drops at the tip of the pipette down inside, right? Because this 1 drop or 2 drops have already been calibrated. So now that's all you need. Now you can see you have a clear colorless acid, clear colorless base. We're going to add 1, 2, 3 drops of our phenolphthalein as our today's titrations indicator, all right? And that's all. Because the background, it's colored, it's a dark colored, say blue or black, so we use a white background now, and then so we can see our color change much more easier. And make sure you understand that this is burette stand. It's simply as an orange stand, and it can be left up or down, and to the left or to the right. All right, so you don't have to strain yourself. We're going to lower down like so. All right, remember the titration speed should be 1 drop per second, 1 drop per second. So a good titration, it's not instant, should be somewhere around 3, 4, 5 minutes. All right, so and then so at the very, very beginning, you can adjust this speed. All right, so we're going to start this is too fast, all right? Much more faster than da, di, da, di, da, di, da. This is a bit of a too slow, okay? So now, di, da, di, da, di, da, di, da. That is a good one. So now, when you have a right speed, and then you're going to keep agitate your swirl our solution, and then to react the analyzer and titrate, all right? And try not to adjust it anymore, all right? Titration is one person's job. Should it be one person look at the color, that person also controls the stop clock, all right? Stop clock, all right? So the other person will be just waiting and then to see if there is an accident. That's all, and then, all right? So make sure you have that. So just keep shaking. Okay, keep shaking, all right? Drop a second. Try not to do it too fast because you're going to missing the point. All right, now I'm going to, no, this is far from it because I know where it should occur. And so it's just, all right, now if you have a drop of titrate got on your, say, wall of just rinse with the downlight water. It's very good speed, all right? So don't try to speed up. Now you can see the pinkish color stays a little bit longer. So now you want to slow down the speed, maybe 2 drops, 1 second, all right? Or maybe 1 drop, 3 seconds, all right? So, okay, good. Beautiful. Another one, beautiful. All right, it is a slow process, and then try not to do it too fast. All right, this is very good. Maybe 1. I think we need probably just this half drop. No.
While adding sodium hydroxide to the acid flask, remember to swirl vigorously.
Last few drops, very crucial. All right, now I think we need 1 more drop, maybe, or maybe 2 more drops. I don't know.